Alright, we're going to look at several examples from class in 2.3. So you should watch this video before Thursday on product and quotient rule. So we're going to take the derivative, and I actually changed this so it works out better in two ways, both using the product rule and using the quotient rule. So in order to use the product rule, I need to change this x plus 1 all over x into something that is in the form to use product rule as a product of functions. So x plus 1 times x to the negative 1. So now that's in something that we can use the product rule on because it's a product of two functions. So we're going to take the derivative of the first. So the derivative of the first is just 1. Derivative of x plus 1 is just 1. Then we're going to take the derivative, or I'm sorry, it's the derivative of the first times the second, so the x minus 1 stays put. And then we're going to add the first function times the derivative of the second. So when you take the derivative of the second, the negative 1 comes down. So we have to use the power rule also, so we're combining some rules here. We get x to the minus 2. So this gives me x to the minus 1. Well, let's see, I'm skipping a bit of steps here. So instead of what I was just going to say, I'm going to factor out the lowest power of x, which is x to the negative 2. So the negative 2 comes out. And what's happening here is I'm going to subtract from this negative 1, I'm going to subtract negative 2. So negative 1 minus negative 2 is positive 1. So that's where this came from. Oops, let's put that 1 in there, okay? Then for the second term, the x plus 1 times the negative 1 will become this negative x and negative 1. When I factor out the x minus 2, this x minus 2 is sitting out in front here. So now we have x minus x, which is 0, and then we just have the minus 1. So the minus 1 is in the numerator and the x squared in the denominator. And we're going to take that same problem and we're going to use the quotient rule. Alright, and this one's set up to use the quotient rule pretty nicely because it's a quotient of two functions. So it's going to be the low function times the derivative of the high function. So the low function is x, the high function, its derivative is 1. X plus 1's derivative is just 1. Minus the high function, which is x plus 1, times the derivative of the low function. Derivative of the low function, derivative of x is just 1. So high d low, all over low squared. Okay? And if we distribute this negative sign through, we're going to have a negative x minus 1. So x minus x is 0, and then we'll just have a minus 1 there. So x minus 1 all over x squared. And we have minus 1 all over x squared. So it didn't matter here. We used either the product or the quotient rule. In some instances, it might be nicer to use one or the other. We could have also done another way of doing this is I could have done it like we did in the last section, and the x over x would have become a 1, and the 1 over x would just be 1 over x, and I think we took a derivative of 1 over x. So that would have been another way, but we wanted to illustrate product and quotient rule. So let's look at a couple examples. These are examples we did or will do in class. So let's look at this one. We have square root of x times x squared plus sine of x. So this is a product of two functions. The functions are the square root of x and x squared plus sine x. To make this a little bit easier to do, I'll write this as x to the 1/2 times the quantity x squared plus sine x. And if we distribute that x to the 1/2 through, we could maybe clean it up a little bit, but we'd get x to the 5/2, and then we'd have x to the 1/2 times sine x. So we'd have that x to the 1/2 times sine x, so we'd still have to use the product on that. So if we take the derivative, so we're going to take the derivative of the first, so 1/2 x to the minus 1/2 times x squared plus sine x times the second function plus the first function times the derivative of the second function. So derivative of x squared is 2x. The 2 comes down, x to the first power. And derivative of sine is not minus sine. It should be plus cosine. Sorry about that. All right. And the lowest power, so we're going to do some fancy algebra here. I'm going to factor out a 1/2. Okay, so that 1/2 here. If I factor out a 1/2, it's kind of like I multiply this by 2, and I'm going to have to introduce a 2 over here on this piece. So there's going to be a 2 there, and an x to the minus 1/2. So the x to the minus 1/2 will take care of this, and so let's go ahead, and that takes care of this first term, and we have x squared plus sine x. Now we're going to have plus 2, so that if I FOIL this 1/2 back in, 1/2 times 2 will get me back to the coefficient of 1 there. And then I'm going to have an x there. So if I take the exponent of 1/2, and if I factor out an x to the 1/2, I'm subtracting a negative 1/2. So 1/2 plus 1/2 is 1 whole, so it'd be x to the first power. And again, sorry about that. This should be a cosine, not negative cosine. Okay. All right. So let's clean this up a bit. What's going to happen here is we got x squared, and then the 2x times 2x will be 4x squared. So the x squared plus 4x squared is 5x squared plus a sine x, and it should be plus 2x cosine x when we distribute. All over a denominator of 2 square root of x. Alright, let's look at another example. F of x is equal to x squared all over 2 square root of x plus 1. This is a quotient of two functions. The top function is x squared, so that's the high. The low function is 2 square root of x plus 1. Okay, so low, there's 2 square root of x plus 1. D high, the derivative of the top is 2x, minus the high function, which is x squared, times the derivative of the low function. So there's going to be a 2 there, and square root of x is x to the 1/2 power. So the 1/2 comes down, and subtract 1 from the exponent. So 1 minus 1/2, I'm sorry, 1/2 minus 1 is negative 1/2. And the derivative of the 1 is 0, so we don't put the 0 in. All over the low squared. Okay. And we can do a little bit of cleaning up here. So if I distribute the 2x times the 2 square root of x, that'll be 4x square root of x plus 2x minus x squared times x to the minus 1/2. We'll add those exponents, so that'd be giving me 1 1/2 or 3/2. The 2 times a half will cancel out. All over 2 square root of x plus 1 quantity squared. And we get 3x to the 3/2. So x square root of x, if I change that, x square root of x is really the same thing as x to the first times x to the 1/2. And when I multiply like bases, I add the exponent, so I have 1 and 1/2. Well, 1 and 1/2 is the same thing as 3/2. So the 4x square root of x and the x to the 3/2, they're actually the same. They're actually the same term. So 4 minus 1 gives me 3 here, 3x to the 3/2, plus 2x, all over the denominator squared. And most of the time, I would say almost all the time, you don't want to square out the denominator because it's just going to make it a giant mess. Alright. Let's look at C. F of theta is theta plus 1 times the cosine theta. So when we take the derivative, it's the derivative of the first, so theta plus 1, the derivative of theta will be just 1. Derivative of the 1 will be 0, so it's just 1 there. and then times the second function, cosine theta, plus the first function, theta plus 1, times the derivative of the second. Derivative of the cosine is negative sine. And then we can go ahead and clean that up. So cosine theta and distribute minus sine theta, minus theta sine theta, minus sine theta. And that's it. So pretty straightforward. D, f of x equals tan x. And to do this, we're going to write this as sine x over cosine x. And this looks like a quotient of functions. So when we take the derivative, it'll be low, which is cosine x, times d high. Derivative of the sine is cosine, minus the high function, which is sine x, times the derivative of the low function. The low function's derivative, the derivative of cosine, is negative sine, all over cosine squared. So f prime of x is equal to cosine squared x plus sine squared x all over cosine squared x. And remember, in the previous video, cosine squared plus sine squared is 1, or from pre-cal, you would have seen that also, or trig. So this would be 1 over cosine squared, which is the same thing as the secant squared x. So the derivative of tangent is secant squared. It'd be nice if you could have that memorized. If you don't remember it, you can always derive it using the quotient rule. Okay. All right, let's look at another one. E is, we're going to take the derivative of the secant x. So secant is 1 over cosine. So it's going to be low times, I was thinking 0 here, so let's try again. So this should be in, no, we're okay, sorry. I was not reading it correctly. So the low function is cosine x. The high function's derivative, the derivative of 1 is 0. Minus the high function, which is 1, times the derivative of the low function. The low function's derivative is going to be negative sine x, all over the low function squared. Cosine squared x. And we can write this as sine x over cosine x times 1 over cosine x. So we have two cosines in the denominator, so we can write it in this form. So that'll give us that derivative of secant is tan x secant x. In class, we might do cotangent's derivative and the cosecant's derivative, but they're going to be very, very similar to what we just saw here. So you can try those ones on your own. Okay. Let's look at h. Conveniently, we call it h of theta. So we're going to go ahead and apply. So we just saw what the derivative of secant is and what the derivative of tangent is. So our function is 5 theta secant theta plus theta tan theta. So we're going to be using the product rule twice because both functions, this 5 theta secant theta is a product of functions. The 5 theta and the secant theta are both functions, and then theta tan theta. So those are both functions. So it would be 5 secant theta. So the derivative of the 5 theta will just be 5, and then the second function is secant plus the first function, 5 theta, times the derivative of secant theta, which we just saw the derivative of secant theta is secant theta tan theta, plus tan theta. So the derivative of the theta is just 1, so tan theta is left over, and then it'll be theta times the derivative of tan, which is secant squared. And I don't think there's a whole lot you can do with this. You might try factoring, but it didn't seem to go anywhere. So this is just how we're going to go ahead and leave it. Okay. Let's look at letter I. F of x is cube root of x times square root of x plus 3. And I'm going to go ahead and rewrite this in the friendlier exponential notation. So we have a product of two functions. X to the 1/3 and then x to the 1/2 plus 3. So when we take the derivative of the first, or am I going to be a little bit more clever here? I think I am. So we are practicing the product and quotient rule, but I saw that this one I might be able to be a bit more clever. So I was just asked to take the derivative, and it would probably be easier to actually just distribute that x to the 1/3 third through. So that's what ends up happening here. 1/3 plus 1/2 is 5/6 if we find common denominator, and then x to the 1/3 times 3 is 3x to the 1/3. So I'm going to use the power rule. 5/6 comes down, subtract 1 from your exponent. 5/6 minus 1 is negative 1/6 plus 3, and then the 1/3 exponent comes down, x to the minus 2/3. And we'll go ahead and just rewrite that. 5 over 6 root of x plus 1 over cube root of x squared. You could find common denominator, but this is probably good enough. Alright, one more example. J. F of x is equal to c squared minus x squared over c squared plus x squared. I think on my handout there may have been a bit of a typo. I don't remember exactly what was different about it, but this is what it should have been. Alright, so low function c squared plus x squared, d high. C squared is a constant, but the derivative of minus x squared is minus 2x. So there's low d high minus high d low all over low squared. We'll go ahead and distribute in the numerator to give us negative 2x c squared plus x squared. But I think I was a little bit more clever than that. So one way you could do this is you could distribute the minus 2x through. But I saw that I had a negative 2x and 2x, so I factored out a negative 2x. So here's the negative for this 2x, and this negative 2x already had a negative, so that's where the negative 2x came from. Let's get rid of that stuff. And we have c squared plus x squared. I took this negative sign out, and here's the c minus x squared. So you see that the x squareds are going to cancel out. And we'll have negative 4x c squared all over c squared x squared squared. Because I had a c squared and a c squared, I had 2 c squareds times 4 gives me 4. I'm sorry, c squared plus c squared is 2 c squareds. 2 times 2 is 4, so that's where this 4 came from. Okay.